Hello, and welcome back to the Python Basics tutorial. In the previous video, I covered the types of data collections and the vast amount of operations that could be done on each type. In this video, I'll be covering control flow, or where Python will travel through our code within if statements, for loops, and while loops. I'll start with if statements. Here we have a basic if statement with two lines. We have the if keyword and a condition that will always return a Boolean value, either true or false. And then we have our statement here, print hello world, if the condition does in fact turn out to be true. In this case it is, so if we press the run command, you can see we have hello world. And we can also print out the if statement in one line. So if true, we print hello world. Generally this is frowned upon, so it's common practice to write out your statements on separate lines, but you can write if statements in one line. Here we have a pass statement. This would be the same as if you had just white space, but since you can't just keep white space within an if statement, Python will continue looking for the statement to run if the case is true. So this is why we have a pass statement that allows you to have nothing within your if statement. So if we run this, you can see that nothing happens because we just have a pass statement. So quick recap on comparison operators. We have the is equal to, is not equal to, is greater, less, greater, equal, less, or equal. These operators can be used to check if values are equal. You can basically compare variables with values or variables with other variables to see if their statements are true or false. So here I have if my variable is equal to 5, which my variable is equal to 5, then it would return my integer variable is my variable. So here we would have my variable integer is 5. And then we can also have the not is not equal to. So my variable is equal to -5. My variable, which is -5, does not equal to 5, so this statement would be true, which means that this if statement would trigger, and you would print my integer variable is -5. Next we have my variable is greater or equal to 9, my variable is equal to 10, so 10 is greater than or equal to 9, which means we would print true. But if we were to put 12, it would not print false, but rather it wouldn't print anything because this if statement would not trigger. Since this statement here would be a false statement, then the if statement wouldn't trigger and this print statement would not trigger. So we also can add arithmetic operators, arithmetic and comparison operators. Arithmetic being, plus, minus, multiplication, division, long division, and modulus. So here we have modulus. My first variable, which is equal to 14, modulus 2 is equal to 0. That is true. So this statement would print my first variable is an even number. And here we would have my first variable, modulus 2, is equal to 1, which is not true because 14 divided by 2 does not have a remainder. Then we would say my first variable is an odd number. So if we check this, we can see that my first variable is an even number. But if we were to change my first variable, you can see that I've made it to 13, which means it should have a remainder of 1, which means that this statement would not run. But instead, my first variable is an odd number. This if statement would trigger, and this print statement would run. So you can also have nested if statements, which means that you can have if statements within other if statements. Here my first variable is 10, my second variable is 20, my third variable is 30. So here it says if my first variable is 10, then you print my first variable is my first variable. If my second variable is 20, my second variable is equal to my second variable. And if third variable is equal to 30, then my third variable is equal to my third variable. So here you can see we have all the variables and their values. What's interesting is that if we move all this to the right one, and if we tab, instead of it being nested, now we check for each individual variable. So here we would also get 10 to 30. But instead of it being nested, it would check each individual if statement. So let's say for instance we have the value 14. even though my second variable and my third variable are 20 and 30 respectively, they wouldn't trigger. These print statements wouldn't trigger because this is all one statement that would be run only if this very first statement, if statement, triggers. So you can see it doesn't return anything because my first variable does not equal to 10, it is equal to 14. As such, this is false, and this entire statement would not run. However, if it wasn't nested, then it would check for my second variable is equal to 20, my third variable is equal to 30. So now let's check out the else keyword. So here we have if my first variable is equal to my second variable, we print the first condition is true. However, if this statement is false, then we run this statement. The first condition is false. So my first variable, which is 0, is equal to 1, which is false, which means this statement wouldn't run, but rather this statement would run. So here we check it and we see the first condition is false. So let's use some arithmetic and comparison operators with if-else statements. Here we have my first variable is equal to 10, and if my first variable plus my first variable is equal to 5, then we say the value is 5. And if not, the value is 10. So 10 plus 10 is 20, which is equal to 5, is not true, which means that it would print the value is 10, which it does. So my first variable is equal to 10. This is very similar to the to this problem up here, where we check to see if modulus 2, using modulus 2, we could check to see if the variable is even or odd. But instead of having this second statement, what we do is we just say, okay, we can have an else statement, because we know that if my first variable modulus 2 does not equal to 0, then it must equal 1. So here we have my first variable is an even number, and then else my variable is an odd number. So 10 modulus 2 is equal to 0, then it would be an even number, but else it would be odd number. So this should be even, which it is, because 10 divided by 2 has no remainder. Next we have arithmetic comparison and logical operators within if-else statements. So here we have 10 and 20 as two different variables. If my first variable modulus 2 is equal to 0 and my second variable modulus 2 is equal to 0, then we print both conditions are true. So logical operators, remember, are and, or not operators, and here we have the and statement, which means that in order for this entire statement to be true, we need both the left and the right sides of the and keyword to both be true. So here we have my first variable modulus 2, 10 divided by 2 has no remainder, which means that the left side is true, and then my second variable modulus 2, which is 20, my modulus 2 also has no remainder, so the right side is also true. Since both the left side and the right side of these statements are true, then this entire statement will return true, which means that both conditions are indeed true. And indeed, both conditions are true. So now we can have a nested if-else statement. This is where things can get a bit complicated, but we'll go through it bit by bit. We have my first variable is equal to 10, my second variable is equal to 30, so now we check to see if my first variable is equal to 10, which it is. So then we print my first variable is my first variable. But then we also have another if statement, so then we say, okay, if my second variable is equal to 20, then we print my second variable is equal to my second variable. This is false, which means that this if statement does not trigger. So this print statement never occurs. Instead, we go to the else statement, which says, okay, my second variable is equal to 20 is false. So if my second variable is equal to 40, then we print my second variable is equal to my second variable. My second variable does not equal to 40, so in this case, this print statement also wouldn't run, but rather we would go to this next else statement, and then we would print my second variable is my second variable. So here we have my first variable is 10, and my second variable is 30. So you can see even in else statements, we can also have if statements and else statements. So now we'll learn about the elif else statement. what this basically does is this checks to see if another if statement, if another condition is possible, only if this first if statement is not possible. Here we have my first variable is equal to 50, my second variable is equal to 100. If my first variable, which is 50, is equal to 100 for my second variable, then you print the first condition is true. This, unfortunately, is false. This does not happen. So this if statement does not trigger, this print statement does not occur. So elif, my first variable is less than my second variable. 50 is less than 100, which is true. In this case, the else statement does not print either. It also does not trigger. In this case, the second condition is true. So let's use some comparison operators in some if, elif, else statements. We have my first variable is equal to -1, my second variable is equal to 2. So here we say if my first variable is equal to 0, then we print my first variable equal to 0. This is not true, so then we move on to elif, which says if my first variable is greater than 1, this is not true. Because my first variable is less than 1, then we say print my first variable is greater than 1. This also does not trigger. And then we have another elif statement, which says if my first variable is equal to my second variable, which it is not, -1 does not equal to 2, this statement also does not trigger. So all of these three statements do not trigger, which means we go to the else statement, which says my first variable is less than 0, which it indeed is less than 0. Alright, next we can use some logical operators as well with some comparison operators. Once again, logical op being the and or operators. Here, if my first variable is equal to my second variable and my first variable is less than 0. So this has to be true and this has to be true for both of them for this whole statement to be true. So my first variable is equal to my second variable. Yes, that is true. 2 is equal to 2, so this statement is true. And my first variable is less than 0. This is false. And since one of these is true and one of these is false, with an and symbol, this entire statement will be false. So this print statement will never trigger. So then we have an elif statement, which says my first variable is greater than my second variable, or my first variable is greater than 2. 2 is not greater than 2, or 2 is also not greater than 2. And since both of these statements are false, even with an or statement that only checks to see if one of these cases are true, since both are false, this print statement also would not trigger. Then we have elif not my first variable is greater or equal to my second variable, which basically says if my first variable is greater or equal to my second variable, where 2 is greater or equal to 2, this statement would be true. But since we're using not statement here, true is false and false is true, which means our true statement turns into false. This print statement does not trigger, which means that the else statement triggers and all conditions are false should be printed to the console, which it is. Next, we have comparison operators within nested if, elif, else statements. So you can nest basically a lot of if statements, else statements, and elif statements here. But let's take a look. So my first variable is equal to 1, my second variable is equal to 2, and my third variable is equal to 3. If my first variable is less than my second variable, then we continue on. My first variable is indeed less than the second variable, so then we have if my first variable is greater than my third variable, which it is not, which means this print statement never triggers. Then we have elif my first variable is equal to third variable, it is not, 1 does not equal to 3, so this statement does not trigger. Then my first variable is less than my third variable, which indeed is true, so this print statement will then be triggered. 1 is less than 2, but greater than 3. And if we print it out, it says 1 is less than 2, but greater than 3. So next we have for loops. Here we have a basic for loop with a range function. Range function is basically a list of integers from 1 to 10. Really quickly, I can just print range 10. And you can see that our range is from 0 to 10, but if we print for I in range 10, then we print I and then end with a space. This is actually not necessarily, this is not really necessary. We can print them all on separate lines, or we can use this end is equal to a space, which means instead of printing each value of I on a new line, we can just print it onto after a space. So here we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We can also iterate through a list. So let's say we have a list already preset rather than creating a list using the range function. What we can do is we can basically say, okay, I want to grab for name in my fish list. This name would be a variable that's assigned to each element. We say, okay, this element, then we would want to print it out. And then we can change our end statement to be a semicolon rather than just a space. So here you can see we have bass, red snapper, carp, pike, perch, which is all the elements within the list, and the semicolon used as the separator after each element. Now we could also iterate through a string. Once again, strings are data collections of characters. Here we have for I in a string of bootcamp May 23rd to 2023. We print I and then end. So in this case, we would receive the whole string, except between each character there is a string. There's a space. And then we have a loop iterating through an integer list. So here we basically have the same thing, very similar to the string. We basically say I want 1 space 2 space 3 space 4 space 5, and that's exactly what we get. 1 space 2 space 3 space 4 space 5. Except this time it's just with integers and not with strings. But it doesn't have to be lists. We can also use tuples, we can use dictionaries, and we can use sets. So here we have 1, 2, 3, 4, 5, and we have the exact same thing, just 1 space 2 space 3 space 4 space 5. And then we have dictionaries. So here what we can do is we can iterate through the keys individually, or we can iterate through the values of each key. So the way we would do the values would be with I, the way we would do the keys is with I, and the way we would iterate through the values is with using my dictionary sequence, the name of the dictionary, and then indexing at I. So here I'm just going to comment this out to see what happens. And here we have key 1, key 2, key 3, key 4, and key 5. Key 1, key 2, key 3, key 4, and key 5. But if we wanted to iterate through the values of each key rather than the keys, then we would use the name of the dictionary and the index with I, and then you can see we have 10, 20, 30, 40, and 50. So that would be an example of how you would iterate through a dictionary. And then there's a for loop with a set. So here we would just have 1, 2, 3, 4, 5, all with spaces between. And then if we use the keys method for a dictionary, we could actually just say for I in my dictionary sequence.keys. That would also be a way that you can just grab the keys individually. And then the values would also be the way to get the values of each key as an iteration. And then if you want both the keys and the values, then you can use .items as the keyword, and here you get a tuple of each key value pair. So here we have a for loop with an else statement, just like if else statements. once this for loop is done printing, then it will print this after it's done iterating. So here you can see 1, 2, 3, 4, 5, this sequence is over. So this else statement is used to print things after the for loop. Now we also have the break statement, and what this means is that basically it'll break out of the for loop and it will stop iterating immediately once a condition is met. So here you can see for I in first list, so first it goes 1. If I is 1, which is not, then it does not do this break function, which means it'll print I is equal to I. So here you have I is equal to 1, and then I increases to 2. So then if I is equal to 3, it's not, it is 2, then it won't break, then it will print I is equal to 2, and then I becomes 3. And then it says if I is 3, then it will break, and once it breaks, then it stops this for loop immediately. And you can see that's exactly what it did, since it did not print I is equal to 3. Then we have a for loop with an arithmetic modulus operator and a continue statement. So here we basically say, I want only the even values within this list. What I would do is I would say for I in my first list, if I modulus 2 is equal to 0, basically if an even number divided by 2 has a remainder, which it does not, then I would just say continue. So here, if I wanted all the even values, I would use 1 because continue skips this next print statement and instead it goes straight back to the for loop and increases the value of I once again. So here we would get all the even values, which is 2, 4, 6, 8. But if we did want all the odd values, we can use 0. So basically what this does is that if I is even, then it will increase rather than going to this print statement. So here we have 1, 3, 5, 7, 9. And then we have an arithmetic operator, modulus operator, with a pass statement. So we don't have a break, we don't have a continue, but rather we have a pass. And what this really does, again, is nothing. So just imagine this as white space, but we can't have this here, so we created a keyword that represents literally just white space. So for I in my first list, if I modulus 2 is equal to 0, you don't do anything, you print it anyways, which means that it will include all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. But you can also have a nested for loop. So let's say you have a for loop within a for loop. 1, 2, and 3, and 1, 2, and 3. If we wanted to print all the values of I and j between 1 and 3, you will see we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So basically it just took each value and added it to the other. A nested for loop with an innermost break. So what happens now is that you have for I in my first list, which goes from 1 to 3, for j in my second list, which also goes through from 1 to 3. If j is equal to 3, then it breaks. So let's take a look at what this does. You can see that 1, 1, 1, 2, but we don't have a 1, 3 because I would be still 1 and j would be 3, and since j would be 3, it would break the original for statement. This break statement only breaks to the first for statement, or while statement actually, but it does not break it completely. So even though we have reached that break statement, it only breaks out of the first one, which means I then iterates once again, it goes up to 2, and then it's 2, and for j in my second list, which is 1, so then it goes to 2, 1, 2, 2, and then 2, 3, j is then equal to 3 once again, the for loop breaks, and then I iterates again to 3, and then it goes to 3, 1, for j in my second list is 1, so 3, 1, 3, 2, and then 3, 3, 3, 3 breaks again, which means this print statement is never triggered if j is equal to 3. Then we have a nested for loop with an outer break statement. So the place in which we put our break statement actually matters because we we're looking at basically which for loop is actually broken. And in this case, for I in my first list, if I is equal to 3, then we break, but for j in my second list, we just print j. So in this case, we only have 1, 1, 1, 2, 1, 3, and we have a 3 value in here because here it's j, and we don't check for the value of 3 for j, we check for the value of 3 for I. So then, once we reach the value of 3 for my second list, I iterates once again, it goes to 2, and then we have 2, 1, 2, 2, 2, 3, and then I is equal to 3 for all the values of j. So it would be 3, 1, 3, 2, 3, 3, and since I is equal to 3, it breaks and this for loop is does not trigger any longer. Next we have a nested for loop with an innermost continue statement. So instead of having a break statement, now we have a continue statement. So here for I in my first list, for j in my second list, for j is equal to 3, we continue. So we have 1, 2, 3, and 1, 2, 3. Once again, the continue statement goes to the for j statement rather than breaking completely. So if j is equal to 3, then rather than printing it out, it would just iterate j once more. So when we run this, we should see that we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 1, 1, 1, 2, 2, 1, 2, 2, 3, 1, 3, 2. So what's really happening here is that we have when j is equal to 3, this should not print. Let's check a nested for loop with an outer continue statement. Here we have for I in my first list, if I is equal to 2, then we continue, and for j in my second list, we would print string I and string j. So here we have 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 1, 1, 1, 2, 1, 3, and 3, 1, 3, 2, 3, 3. Here when we continue, we iterate I once again. So when I is 2, it goes to 3, and then we have 3, 1, 3, 2, 3, 3. Next we have a nested for loop with an outermost pass statement. So this would do nothing, because pass, once again, is just like white space. It would return 1, 2, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 2, 3, 3. 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. Oh, this is why. Okay. I see. I see. So here when we print it out, we get 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. There's no change because of this pass statement. So now we have list comprehension. So what this basically means is that if I want to create a list, I can use a for loop within that list to create the list. So here we have an example of what is list comprehension. We have a variable called myNumberList, and then we have square brackets, and inside we have mynum for mynum in range 1 to 6. This looks a little bit complicated, but let's print it out and see what we got. Here we have a range from 1 to 6, and since 6 is at the end of an index, we don't include it. So we have 1, 2, 3, 4, 5. But let's break it down so we can actually see what's going on here. When we say mynum for mynum in range 1 to 6, we can actually break this single statement into multiple statements for a bit of a more of a clear understanding. We have myNumbersList, which is an empty list, and then we have the for statement, mynum in range 1 to 6, myNumbersList.append mynum. So you can see that's what really goes on here when we use list comprehension. mynum for mynum in range 1 to 6. And then we have another, a little bit more complicated one, where we have mynum plus 10 for mynum in range 0 to 10 if mynum modulus 2 is equal to 0. So here we made it a little more complicated. We have an if statement, and we also have a return value of mynum plus 10. So what this should return is it should return all even values plus 10. So it would return 12, 14, 16, 18. And that is exactly what it returns: 10, 12, 14, 16, 18. But just for a little bit of a more clear understanding, we'll once again break it down. Here you can see what we start with. My number list is equal to a list in here. And then we say for my num in range 0 to 10, we say if num modulus 2 is equal to 0, so we check to see if it's an even number or not. Then we say my number list dot append my num plus 10. The first statement in here is always appending to the list. And then if we print it once again, it'll be the exact same value: 10, 12, 14, 16, 18. So that's how you do list comprehension. We can also use list comprehension with nested for loops. So now we have n for m in range 0 to 3 for n in range 0 to 3. So if we print this, then we get 0, 1, 2, 0, 1, 2, 0, 1, 2. Again, we don't include 3 because we don't include 3 in the index of a range. So we have, here we have the breakdown. A regular for loop, which is, here we have our numbers list that we created. And then in this statement we have for m in range 0, 3, and then we have another for n in range 0, 3, and then we say my number list dot append n. We only count for n, not m. So we have 0, 1, 2, 0, 1, 2, 0, 1, 2. Finally, we have while loops. So what this does is a while loop will continue running the statement as long as the condition that follows, that is like connected to the while loop, is true. So this statement would be false, which means nothing happens because this while statement does not run. Now this statement here, while true, we would print an infinite loop because this statement will never become false. This statement will always be true no matter what, and this statement I refuse to run on my computer because I do not want to crash it. So let's take a look at some while statements. Here we are using a comparison operator. We have the less than sign, we have I is equal to 0, and my first variable is equal to 5. So in this case, what we do is we say while I is less than my first variable, while 0 is less than 5, then we print what I is, and then we add the value of 1 to I every single time the statement runs. So you can see it starts with 0, because 0 is less than 5, we have print 0, and then we add 1 to it, and then it keeps adding up until 5 is less than 5, which is false, at which the while statement shuts down. It basically stops working. But we can also use the we can also use the break operator within a while statement. So here we have while I is less than 5, print I, and if I is equal to 3, then we break it. So this statement also works with while loops and for loops. So when we run it, it should return 0, 1, 2, because 3, also 3 is included because the print statement is before the if statement. But if we were to put this after, then it would only return 0, 1, 2, because I would be equal to 3, and the statement would break before it is able to print 3. So here you can see it would be 0, 1, 2. So the print statement also sometimes matters when you're talking about the position of it. So here we have a comparison operator and a continue statement in a while loop. We have my first variable is equal to 5 and I is equal to 0. So here we have a continue statement. And then we have while I is greater than 5, less than 5, I plus 1. If I is equal to 3, then we continue. So here we would get 0, 1, 2, 4, 5, because when I is 3, we do not use the print statement, but rather we just iterate I once more. So you can see that's exactly what we get. 1, 2, 4, 5. And then using a pass statement, nothing happens, so we're just going to get 1, 2, 3, 4, 5. But much like how for loops can have else statements, while loops can also have else statements, which just print something after the while statement has occurred. So here we would have 0, 1, 2, 3, 4, and then we would have I is not less than 5 anymore. You can see that's exactly what happens. 0, 1, 2, 3, 4, I is not less than 5 anymore. Now we can also have nested while loops. Much like how we can have nested for loops, my first variable is equal to 5, j is equal to 0, and then you say that, okay, while I is less than 5, you print I, then you iterate once through I, and then you say while j is less than 5, then you print j, and j is equal to 1. This is very similar to a for loop, but here you can see we do 0, 0, 1, 2, 3, 4, and then 1, 2, 3, 4. This first 0 is I, because first we print I to be 0, and then we go into this next while function where we see that first we have the value of 0 for j, and then 1, and then 2, 3, 4, and then once it becomes 5, then it breaks out of this while statement shuts down, and then we go back to this while statement, which basically says, okay, now that this is done, now we iterate I once more, and then we have to print the rest of I. So this 1 would be I, 2 would be I, 3 would be I, 4 would be I. Now we have nested while loops with break statements. Break statements. There we go. So we have my first variable is equal to 5, j is equal to 0, 0, and then we have while I is less than 5, print I and j, while I plus 1, while j is less than 5, j is equal to 1. If j is equal to 2, then we break. So once again, this break statement only refers to this while statement. So as soon as this break statement occurs, then this whole while statement shuts down. And here we can see that we would get 0, 0, 1, 1, 1, 2, and then as soon as it becomes 2, then we break out of the first while statement. So then we have 2, 3, 2, 4, 2, 5, 2, 6, 3, 5, and 4, 5. And then I is no longer less than 5. This else statement is always run after while loops. Alright. Then we can use nested while loops with a continue statement rather than a break statement. Here we have a continue, so instead of shutting down this while loop once j reaches 2, instead it will continue and go to this while statement. But as you can see, it's now 3 instead of 5, which means that once j does reach 2, and it will continue, it'll only run once more, because then j plus 1. So you can see we'll get 0, 0, 0, 1, 1, 3, because we skip the printing of j is equal to 2, and then 1, 3 once again, and then 2, 3. And then also the else statement, print I is no longer less than 5. And then we have nested while loops with else statements. Even though we've had an else statement in all of our while loops, what we do here is we just we have a pass statement. Sorry, this should be pass, not else. So here we have a pass statement, which means nothing will happen at the end of this while loop. We also have an else statement within our first while loop. So when we pass, nothing happens, so we should get 0, 0, 0, 1, all the way to 5 for both of them. 0, 0, 1, 0, all the way to 1, 5, and then 2, 5, 3, 5, 4, 5. And I is no longer less than 5. Alright, that has been conditional flow. If statements, else statements, for loops, while loops. Hopefully you understood topics I covered, and I will see you in the next video. Thank you so much for watching.